What's up guys, welcome back to the channel. Today on this video we'll be explaining the exponent laws that you see here. As you can see, we have 9 exponent laws on this video. Now we're going to explain each and every law separately, and we're going to make some examples so that you can able to apply this law. But before we explain these laws, we're going to start by introducing exponent, explain the basics on exponent, things like the base and the exponent, so that you can know what's the difference between the base and the exponent. So let's start by introducing exponent, then we start with this law till the last one. So if you really want to understand these laws, I would say watch this video to the end, because I'm going to go deep on these laws. All right, as you can see here, we have the following notation here. We have a number. In this case here, this number, we call it a base. And then we have n there, which is, in this case now, this n is the actual exponent. So here it's a to the power of nth, or nth exponent. So this n here represents how many times does the base multiply itself. So an example could be something like this. Let's say you have 2 to the power of 3. So as you can see, the base here, it's 2. And then the exponent here is actually 3, right? So this basically means that the base multiply itself 3 times. So it's going to be 2 multiplied by 2 multiplied by 2. This 2 multiply itself 3 times, as you can see there on the exponent. Now the answer here obviously is going to give us 8. That's what exactly exponents are. Sometimes you can be given a variable that is not known. For example, you can be given x to the power of 2. This basically means that x multiply itself twice. Remember, the number of an exponent here, it means that this base is multiplying itself 2 times here for this one. As for this one here, it means that this base, in this case, which is 2, multiply itself 3 times. So hence we have 8 there. Now that we know what is the base and what is an exponent, let's start with the explanation of the laws. So we're going to do law 1 and explain it further. Right, here is our law 1. Law 1 states that we have the base and the exponent there is 0. So the answer is going to be equaling to 1. Basically, this means that anything to the power or with an exponent of 0 should give you 1. So we can say 2 to the power of 0. This is going to give us 1. Anything, guys, you can say 1000 to the power of 0. This also is going to give you 1. This is one of the laws that you need to know, guys, when you do exponents, because it's very important for you to understand this, because sometimes we are required to change maybe 1 into a certain variable. For example, something of this sort. It depends on the question. So if you know this law, you can go either way. You can go this way or you can go the other way, depending on the question that you'll be asked. This is the first law on this video that we are explaining. I hope you can able to understand, guys. You can also be given a question like this, maybe a to the power of 0 there. This is also going to give you 1. As long as the power or the exponent is 0, the answer is always 1. Do not forget that, guys. So let's move to our second law and let's explain it further. All right, let's look at law 2. Now law 2, when we have the base to the power of negative exponent or negative nth, the answer is going to be 1 over a to the power of nth. So let's see if we can able to do some actual examples here. Let's say we have 2 to the power of negative 3. In this case, 2 is our base and our exponent here is negative 3. Now you can rewrite this according to this law, 1 over 2 to the power of 3. If you remember that if we have the exponent, it means that the base, it multiply itself by that number of exponent. In this case now, the base here, which is 2, is going to multiply itself 3 times. 2 multiplied by 2 multiplied by 2. Now at the end, this is going to give you 1 over 8, or as 0.125 in terms of decimal. So let's make another example. Let's say we have maybe 3 to the power of negative 2, like this. Again, as you can see from this law here, it's going to be 1 over the base to the power of the exponent. As you can see, when the base is on the denominator, this exponent changes the sign. It was negative, now it's positive. So this is the same as 1 over 3 multiplied by 3. So because our exponent here is 2, this 3 multiply itself twice. So this is going to be 1 over 9. There we go. Now, if you continue, this is going to be approximately going to be 0.111. Better leave it with 3 decimal points, guys. But this law here basically explains that whenever your exponent is negative there, your base become a numerator, and the very same exponent there comes positive, as you can see with this one here and with that one there. So this is law 2, guys. If you come across this, do not forget to apply this law. Now let's look at law number 3. All right, guys, so here is our law 3. Now law 3 states that whenever you have the base and the exponent inside the bracket, and you also have the exponent outside the bracket, the exponents here, they're going to multiply each other. All right, guys, let's make an example. Now let's say we have x to the power of 2 inside the bracket, and outside we have the exponent of 3. Now when you follow this law here, it states that our base, which is x, is going to be x, but then when it comes to our exponent, it's going to be 2 multiplied by 3. So at the end here, this x is going to be x to the power of 6, because 2 multiplied by 3, that give us 6. Sometimes we can be given something like this. Let's say you have 2 to the power of 3, then outside there, let's say we have 2 there. Now if you continue, you solve this one here. Remember, the base here is 2. So the exponents here, they're going to multiply each other. It's going to be 3 multiplied by 2. So at the end here, we're going to have 2 to the power of 6. This here is going to give you 64. This basically means that this 2 that you see here, it multiplies itself 6 times. Let's expand it there. It's 2 multiplied by 2. That's 2 times multiplied by 2. That is 3 times multiplied by 2, 4 times multiplied by 2, that is 5 times multiplied by 2. Now if you put this on a calculator, this is going to give you 64. This is basically what it means when we have something like this. Sometimes you can be given something like this. Maybe you have 3 to the power of 1, and then we have 2 there. Again, this is the same as 3, the base here, 1 multiplied by 2, and this is going to give 3 to the power of 2, and that at the end is going to give you 9. Guys, this is the third law, or law 3. So it states that whenever you have the base with an exponent inside the bracket, the exponent is going to multiply the exponent outside the bracket, and that is going to give you these results that we have here, guys. I hope you can understand this one, guys. Let's go and explain law 4. All right, let's look at law 4. Law 4 states that when you have two bases or more that are the same and they are multiplying each other, their exponent will add them. An example could be something like this. Let's say you have 2 to the power of 3 multiplied by 2 to the power of 4. This here is going to be 2. Since the bases are the same, the exponent here they're supposed to add. It's going to be 3 plus 4. So when you continue, we're going to have 2 to the power of 7. So this is going to give us 128. Let's make another example. Let's say we have x to the power of 3 multiplied by x to the power of 2. Right? As you can see, again, our base are the same here. So these exponents here, they have to add each other. So it's going to be x. But as for exponent, they're going to add. It's going to be 3 plus 2. So at the end here, this is going to give us x to the power of 5. So let's make the last example. Let's say we have y to the power of 3 multiplied by y multiplied by y to the power of 4. As you can see, this time around we have 3 bases which are the same, though in this case is y. How are you going to do this one? As you can see from our law, when the bases are the same, the exponent will add. It doesn't matter how many bases we have here, guys. We're just going to add. So first we write the base, and then we start with the first exponent there, which is 3, and then we plus. Remember, this y has the exponent of 1, so we can say plus 1, and then the last one there plus 4. If you continue like this, this is going to give us y to the power of 8. There we go, guys. Basically, this is how you apply this law here, guys. As long as the bases are the same and they are multiplying each other, the exponent they will have to add from this law here. This is where we applied it, this is where we applied it, and there as well. I hope you understand how to apply this law as well. Guys, if you find this video useful so far, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. And also, we have made lots and lot of videos on mathematics. If you want to learn other topics, you can go to the playlist and select the topic that you want to learn. You can also support the channel by hitting the super thanks button. But if you can't do that, a like, comment, subscription, and also a share of the video will be highly appreciated. All right, guys, we're done with law 4. Let's do law 5. All right, guys, here is our law 5. Now, law 5, it's different from law 4. As you can see, if the base are the same, but they are dividing each other, as for the exponent, they're gonna subtract each other. But you should be careful about this, guys. When the base is on the numerator, the exponent there on the numerator, you keep its sign. When the base is on the denominator, the exponent on the denominator changes the sign. So an example could be something like this. Let's say we have 3 to the power of 2 divided by 3. There we go. Let us not forget that this 3 here is the power of 1. So if you continue here, this is going to be 3. Now our exponent is going to be 2 minus 1. Remember, this one here is the one on the denominator. So our final answer here is going to be 3 to the power of 1, which is equaling to 3. All right, let's make another example. Let's say we have x to the power of 5 divided by x to the power of 2. Again, our base are the same here. So this law applies. The one on the numerator, the sign doesn't change for the exponent. You're going to have x to the power of 5. But as for these two here, it's going to become negative. This here become x to the power of 3. There we go. Guys, this is very, very simple. Let's make an interesting example here. Let's say this time around we have x to the power of 2 divided by x to the power of 4. Still, we're going to apply this law. It doesn't matter. As you can see, our base are the same, which is x in this case. Our exponent is going to be 2, but the one underneath there is going to be minus 4. And then our final answer is going to be x to the power of negative 2, because 2 minus 4 is going to give us negative 2. And then our final answer, let us not forget the law that we did earlier, which was the second law, going to be 1 over x to the power of 2. We can go further, guys. We can say 2 to the power of 6 divided by 2 to the power of 3. If you continue here, we know that this is going to be 2 to the power of 6 minus 3. Remember, this negative 3 is the power of the 2 on the denominator. So hence it's negative. Now this is going to give us 2 to the power of 3, which is going to give us 8. So basically, this is how you apply this law, guys. I hope you managed to understand how we apply this law here. Really, it was not that difficult. Right, let's go to law 6. Now let's look at law 6. As you can see on this law, we have two different bases here, guys. They are inside the bracket, and these two bases, they have the exponent of n. So when you simplify this, this is going to be as follows. It's going to be a to the power of n multiplied by b to the power of n. So this n here, or the exponent here, affects this base inside the bracket. Now let's make an example with numbers. Let's say we have, for example, x and y, right? And then let's say they have the power of 3 there. So when you solve this one, it's going to be x to the power of 3 multiplied by y to the power of 3. So this here, guys, is different from other laws because now we have two bases. Now let's make another example. Let's say inside the bracket, we have 2 multiplied by a to the power of 4 there. If you continue here, we know that this is going to be 2 to the power of 4 multiplied by a to the power of 4. People tend to forget to include this power on 2 there. So do not forget that. So if you continue, this is going to be 16a to the power of 4. I hope you can able to understand how to apply this one, guys. It's very, very simple. As long as the base are not the same inside the bracket, the exponent that is outside the bracket is gonna affect both these bases here. So this is law 6. Now let's go and do law 7. Now let's look at law 7. We have different bases here which are dividing each other, but at the same time these two bases are inside the bracket and they have the power of n them. So when you simplify this, both the bases, they're going to have the power of n them. So let's make an example. Now let's say we have x over y, all these are inside the bracket, to the power of 2. When you simplify this, is going to be x to the power of 2 divided by y to the power of 2. So this exponent here is going to multiply with the exponent of these bases inside the bracket there. All right, let's make another example that is more interesting. Let's say x to the power of 2 over y to the power of 3. Outside there, let's make it to have the power of 4. As for the numerator, we're going to have x to the power of 2 multiplied by 4. This exponent here, they're going to multiply each other. And then let's not forget, underneath, we also have a base of y, exponent of 3, but multiplied by 4. If you continue with this one, x is going to have the power of positive 8 divided by y to the power of 12. Let us not forget, guys, that these, they multiply here, guys, right? Let's say this time around we have 2 over x, now to the power of 3. Right, so when you continue here, this is going to be 2 to the power of 3 divided by x to the power of 3. So our final answer is going to be 8 divided by x to the power of 3. This law is not that difficult, so you must remember that as long as you have the bases inside the bracket, the exponent that is outside the bracket is affecting everything that is inside the bracket. All right, guys, we are done with law 7. Let's do law 8. Right, let's look at law 8. Now, when you look at this law here, similar to law 7, if you can see here, we have two bases that are not the same, that are dividing each other. But the difference here, outside the bracket, they have the power of negative n. So when you solve this one, these, they swap, guys. As for b becomes the numerator, power of n. A become the denominator with the power of n. So basically what is happening, let me make an example. Let's say we have x divided by y to the power of, let's say, negative 2, like that. So you can do it this way. You can say x to the power of negative 2 divided by y to the power of negative 2. Now, to change this exponent to be positive, remember here we need to apply law 2 here. Law 2, we have a to the power of negative 1 is equal to 1 over a. This here, guys, you can also do it this way. There we go. These are the same law. Y to the power of 2 divided by x to the power of 2. So these signs here, they have to change. So these exponents here, since they are negative, if you want them to be positive, the base on the denominator becomes a numerator. The base on the numerator becomes a denominator. I hope you can understand, guys. Let's make another example on this one. Let's say this time around we have 2 divided by x, we have to the power of negative 3, like that. When you solve this one here, when I have 2 to the power of negative 3 divided by x to the power of negative 3, our x is going to be x to the power of 3, since this sign is going to be positive. As for 2 is going to be 2 to the power of 3. And then as we continue, this is going to be x to the power of 3 divided by 8. There we go. Guys, I hope you understand this, because this is a combination of law 2 and law 7. Right, let's make last example. Now, another example, let's say with x squared divided by maybe 3 to the power of negative 4. Now, when you solve this, the base x here to the power of 2 is going to be multiplied by the exponent that is outside the bracket, divide by, and then we're going to have 3 to the power of negative 4. Now, when you continue here, this x here is going to have the power of negative 8 divided by 3 to the power of negative 4. So we're going to have 3 to the power of 4. Remember, we're changing the sign of the exponent, so the base is going to be on the numerator, which is 3 here, divided by x to the power of 8. Again here, we're changing the sign of the exponent, so the base here is going to be the denominator. Now, when you continue here, 3 to the power of 4 is the same as 81 divided by x to the power of 8. This is how you apply this law here, which is law 8. Do not forget, guys, when you apply this law, the bases, they swap from the numerator to the denominator, from the denominator to the numerator, because of this sign there. I hope you understand, guys. Just in case you didn't understand, do not forget to leave a comment in the comment section. I'll try to explain to my level best. Now let's look at our last law of this video. Now let's look at law 9. As you can see, law 9 here, our exponent, it's in a form of a fraction. When you simplify this one here, you can change it into such and write nth root a to the power of n. What you should notice here on this fraction, on our exponent, the denominator is our root and our numerator is our power there. So let's make an example that will make sense. Let's start with this one here. Let's say we have x to the power of half. Now half is a fraction here. This is the same as the square root of x. Remember, the square root has 2 there, just in case you didn't know. And our x is the power of 1. The denominator on this fraction, on our exponent, is our root. And our numerator on this exponent is our power. Let's make another example. Let's say we have 3 to the power of 5 over 2, like that. As you can see, our exponent is a fraction. When you change this into such, this is going to be the square root of 3 to the power of 5. Let's not forget that the denominator, which is 2 there, is our square root there. You don't really have to write it, guys, because the square root, we know there is 2 there. And when you continue, this becomes the root of 243. Let's make another example. Let's say this time around we have x to the power of 2 over 3. There we go. So when you continue here, we're going to say cube root. Remember our denominator. This time around, write the cube, guys. From 3 going upwards, we do write it here. And then we're going to have x to the power of 2. Our denominator is going to be our root and our numerator is going to be our power. I hope you guys understand this one because it can be a bit tricky. Let's make the last example. Let's say we have y to the power of 1 over 4. When you continue with this one, we're going to have the fourth root and then we have y to the power of 1. Even if you don't write 1 there, it's still fine. Our fraction there, our denominator becomes our root and our power is our numerator, which is 1. Guys, this is how you apply law 9. So we're gonna do more on sats. So this was just a bonus law because we're gonna do sats later on. All right, guys, I hope this video helped you to understand these laws for exponents. And if really indeed this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed to the channel. You can also support the channel by hitting the super thanks button. But if you can't do that, a like, a comment, and the subscription will be highly appreciated. Thank you very much, guys, for watching. Till next time, guys. Cheers.